Okey. Um, Sebenarnya yang ni kita dah kalau yang apa ni, yang ni kira macam part satu lagi saya rasa. Okey, kalau dalam buku um, Process and Product Design tu lah. Okey. Sebenarnya dia ada dua part lah. Eh? Um, selalunya design kita akan buat untuk nak dapatkan new product. So itu yang biasa lah. Okey. Tapi kalau untuk chapter ni kita akan tengok dia punya apa molekul lah, sama ada yang blended ataupun yang single type of molecule. eh so kita akan cover molecular structure. Okey, macam mana kita nak buat screening sebenarnya. Okey, kita nak buat screening ni daripada banyak building blocks. Okey, so awak dapatkan you punya target component tu lah. eh and then we will select the feasible candidate lah, molecules for and also for the mixture untuk you punya target compounds lah, ataupun solvents and any components that you will use for your untuk you punya product lah. Yeah. And then kita akan of course we will estimate lah the properties and also molecules and as well as mixture lah. So sebenarnya untuk awak select the compounds that suitable for your products, kita tak akan fokus only for the modeling non-experimental, which is by using a software, and not only you choose only for the experimental, but we will use integrated lah. Okay, selalunya kita akan guna non-experimental by using software ataupun computer aided. And then we will verify after the screening, we will verify that the candidate, okay, by using experimental lah. So the purpose of you use computer aided design ni kan, ataupun computer atau simulation lah, kita sebenarnya nak reducekan number of the experiment. Okay, for example from 1000, so that we can reduce to 500 and then reduce it to 200, and then finally you can reduce it to 10, and then from that 10 candidate you confirm whether all those selected solvent is suitable for your product or not, or as a key component lah. Okay, faham Okay, so for this chapter actually I divided into two saya rasa. Okay, sebab panjang sikit lah. Sebab dia ada melibatkan software juga. Uh, Dua ataupun tiga lah, mungkin dua pertemuan. Okay, hari Sabtu nanti dia panjang lah, next week kan, for the next class. So yang tu saya akan cover sampai habis lah, until uh, how to use the iCast software. Okay, so I'm not sure for today where we will until where we will cover introduction and review, of course, frameworks. I think it's until the property prediction. Okay, if you look at that, yang saya cross this is sebenarnya apa yang kita akan sebenarnya later akan cover, mungkin sampai property prediction tu yang kita boleh cover by today lah. Okay, so let's see the overview and also objective. Okay, so kalau tengok chapter ni kita akan divided into two classes of chemical products. So you have to remember. Okay. First is the molecules are identical in the product. We call it as a molecular product. Kan? Ini yang biasa lah. And then yang second is a different molecule. Yang present as a liquid and solution ataupun blend. Yang ini kita mixture blend product. Kita banyak-banyak molekul and then kita blend, kita akan dapat satu produk. For example, if you want to make apa the uh, lotion, right? So dia ada combination many compounds, okay? Or toothpaste. Itu pun sama lah kalau awak tengok yang sebelah sini kan. Paste, paint. This is what we call it as a mixture blended product. Okay? Faham So kena ingat yang dua tu. Okay. So the important questions for good understanding lah isu yang related kepada molecular and also mixture design. So the first is macam mana you nak represent the structure of the molecule. Okay. Ini yang biasa kita nak tengok. Sebab kita ada apa? Vector, group vector. Kita ada building block. How you represent the structure lah. And from that group vector and also building block, how can you generate the chemically feasible candidate molecules and also mixture? Okay. Sebab and is it possible to generate the molecules or candidate molecules in a radical form. For example, CH3, CH2. So that is a radical which is non-stable. But how can we identify and how can we macam mana screening to get the stable molecules lah. Okay, and then we can remove that ataupun kita boleh keluarkan lah the non-stable candidate. Okay. Third is how to estimate the properties of the molecules and the mixture, as well as how to formulate and solve typical molecular and mixture design problems. Okay, so yang ni nanti kita akan tunjuk lah macam mana kita nak dapatkan candidates by using apa macchiato. Saya lupa pula nama dia. Tapi ada macchiato lah. Okay, ujung-ujung tu. Dia punya method. Okay. Okay. So there are actually many ways to design the molecular and also mixture product. Okay. Kalau awak tengok kat sini, for this chapter, I think we just consider on the framework based on the computer aided methods and the software. So kalau yang untuk subjek ni kita memang guna iCast lah. Okay. Tapi kita ada banyak software yang lain lah. Okay. And then first we will identify the promising design alternative model based computer techniques. Kemudian kita akan tengoklah. Kita akan employ first to quickly and reliably reduce search space within the optimal design likely to be found. So kita akan screening benda tu. Okay. Lepas bila you guna computer design, you screening. Later stage you akan verify by using experimentally. Yang ni you akan fine tune nanti. Okay. And then focus experiment perform on identify set of promising alternative. So selepas tu baru you boleh dapat lah. Contohnya from 5 you ada 2 candidate and then you boleh try lah tu dekat you punya produk. Okay. Okay. Sebenarnya topik yang product design ni lagi senang daripada quantum sebenarnya. Batch awak dah ambil yang ni lah SKTK kan. Dah ambil yang product design ni. Kalau sebelum ni quantum mechanics saya ajar juga sebenarnya. Yang tu student susah sikit lah. Okay, product design ni senang sebab dia product kan. Quantum tu tak nampak sangat. Okay, so learning outcomes, if you look at here that there is a 5. I hope that you after you study or you understand this topic, okay, so you boleh recognize characteristic of single molecules and liquid mixture. This is the blended lah, blended and also molecular molecules. Okay, so you able to convert the needs function of the product to be properties of single molecules or liquid mixture. If you remember, how can we convert from the qualitative to the quantitative? Okay, so that is important. Needs, function and also constraints lah. Sebab kalau needs daripada consumer, kalau you tak transfer kepada quantitative, how you measure and how you insert the input into the software. Okay, itu yang penting. Contohnya in term of the smooth of the when you apply the lotion on your skin, right? So it's going to be related with the viscosity. Okay, so how to measure the viscosity? There's the equation you have to use. Okay, and then you have to be familiar with the computer aided methods or software that especially is iCast. I will teach maybe some basic and how to use the ICAS, and then you can explore by yourself. Okay. And able to select, design, analyze product composed of the same molecule throughout the product. And lastly is you can select, design, analyze liquid product. And this is the mixture. I think for designing the formulated products, we will cover in the next chapter. I think this is more to the how to choose how to select the candidates. Okay, molecule candidates for your products. Okay, rather than you design. Okay, I think for the next chapter we will focus on 3 types of the product formulated. What another two? I forgot. Last time I already explained. There's another two, right? Devices and also another one. Eh? Devices and apa? Saya lupa. Okay, but it's okay. But this one is mostly we focus on the formulated. Okay, device is never used. Is rarely used the what is it? Blended mixture. Okay, so for the introductions, kalau tengok kat sini, molecules and the mixture products. Okay, generally is belong to B2 types. Business to business. Okay, we from the petroleum, for example, petroleum gas or oils, right? We produce another what we call it as an intermediate. I can say is an intermediate or another feedstock for another company. For example, you send it to the chemical company, chemical industry, okay, to produce another intermediates of third intermediate, which is can be used by the polymer industry and then convert to another to final product. Okay, maybe can be converted into the bottle, right? So that is the example. So generally is a B2B type. Okay. So yang ni lah molecule ada yang simple, right? And then until it's sampai yang complicated lah. Molecules or mixture eventually help to manufacture a desired chemical based product process. Okay. And then mixture blended products actually is incorporated in the final product and have specified function in the product. Okay, ini yang memang kita punya target lah. Mixture blended. Kita akan guna contoh untuk lotion, sanitizer and so on. Okay, so 3 types of molecular product of varying size and the molecular structure complexity. Kalau tengok dekat sini, yang A is usually have a process related application or maybe part of the mission. Yang ni paling simple lah. Kalau yang B tu untuk active ingredients. Kalau you ingat balik, active ingredients untuk dia punya main lah, key ingredient. Okay, kalau tak ada ni dia tak boleh ni lah buat produk tu. Okay. And the third one is C is kita manipulated lah to a specific product function. Okay. And then ada D, rasanya macam ada D. Okay. Yang last one is the mixture blend. Yang atas tu type of the molecule. Okay. Okay. So let's see for the solvent. Okay. This is one of the good example of both molecular and also mixture product. So kalau awak tengok gambar yang sebelah kanan tu adalah kita panggil separator lah, a type of the separator. This is a distillation. Top tray and bottom tray. Okay. So kalau good example kat sini selalunya kita akan gunakan solvent lah. Okay. Kita ada solvent kat dalam tu. So feasibility of downstream product depend on successful performance of solvent-based operation. Okay, kalau kat sini example dia separation, cleaning operation, right? This is I think for those who work in the chemical industry boleh faham lah. In term of this one. Sekarang pun dah ambil ni kan, apa tu? Process design kan, tengah ambil juga kan, in parallel. Betul tak? Ke tak ambil?
Plan design.
Plan design kan? Betul tak? Okay. Ada ajar ni tak? Apa ni, Aspen Hashi tak?
Ada ni, baru masuk.
Aspen Hashi dah ajar dah?
Ada ni. Aspen lah. Ada ni.
Ada kan? Sebab saya risau nanti for the plan design project, plan design project nanti awak akan guna Aspen Hashi ni sebenarnya.
Cuma itulah dia punya software tu lah.
Software tu
kalau tak ada yang free tau.
Tapi you boleh masuk je dekat UTM tu. Boleh guna. Dekat lab N15.
Ataupun pakai kat UTM punya.
Kalau awak nak minta macam ni, ataupun you minta dekat mungkin boleh masuk UTM dulu, awak install kan. Kemudian bukan install, you control daripada you punya laptop guna TeamViewer. Tapi lab dekat sana kena
ada. Baru je buat assignment dia tu.
Guna TeamViewer guna TeamViewer.
Memang ada buat memang minggu lepas.
Penting lah tu sebenarnya. Kalau tak nanti awak tak boleh buat sebab batch yang sebelum ni dia orang tak ada belajar pula Aspenansis tu, yang saya pelik juga tu. Okay, tak apa. Okay. So yang ni adalah proses industri, tak apa yang tu. Okay, for the formulated products is example is a case cosmetic lah. Okay. Selalunya kita akan deliver active ingredient to skin and then leave by evaporation. Okay. And then actually the performance is depending on the function of the selected solvent. Sebab selalunya kalau kosmetik ni contohnya yang hari tu macam, tapi saya tak tahulah kalau makeup ni ada dia ada solvent ke? Ya tu lah aku tahu. Dia akan evaporate ke? Dia tak ada. Dia kalau yang ada solvent tu mungkin sanitizer lah. Okay, tapi kalau yang ni lotion ni saya rasa lebih kepada dia punya viscosity, pH, right? Itu yang in term of the performance lah. Okay, not irritating to your skin. That is the performance of the product lah. It depend on the function of the selected solvent. That is the important. Solvent is the component lah. Okay. For the single molecular products, for examples, if you use a refrigerant or heat pumps, okay, this one is usually we use a single or nearly pure molecular products. Kalau tengok pun kalau aircon kan, dia akan guna R berapa? R34 ke R14 lah, saya lupa. Okay, dia just single je kan. Okay. So selalunya dia akan exert ataupun release energy lah. Okay. And then another example is kalau tengok kat sini adalah emulsifier. Okay, and also what is it? The active ingredients is the definition of active ingredient, chemical performing the main function of the chemical based product as in drug and cosmetic. Maksudnya dia adalah yang main function ya. Kalau tak ada benda ni dia tak jalan. Okay. Itu memang dia punya active ingredient. Okay. Faham introduction? Okay. For the molecular design product, okay, actually the properties difference lah. Okay, based on the needs and function. Yang ni qualitative and the quantitative lah. Okay. In the process operation or in the downstream product. Okay. So kalau typical molecular design problem kalau tengok kat sini adalah given a set of building blocks and specify set of the target properties, determine the molecules that match these properties. Okay. You ada building blocks. Okay, you ada target properties. You ada, contohnya you nak boiling point lebih more than 100 degree C. liquid it should be in liquid at the room temperature. So you have to match these properties. Okay, molekul apa yang sesuai? Okay, with this target you punya properties lah. Okay, that's why you need a need and function. Okay, daripada situ barulah you boleh dapatkan you punya target solvent ataupun target compound. Okay. Okay, kalau need function of the product tak boleh match, okay, need function of the product match dengan property of single product, okay, so kita akan consider mixture of different molecules, okay, kita akan consider mixture of different molecules lah, okay, so maksudnya you akan test lah, okay. So kalau dekat sini perform operation example adalah blend of the solvent, lubricant, process fluid, okay, perform function additive fuels, solvent blends, okay, and aroma blends dalam cosmetic product. Nanti kita akan tengok macam mana nak tengok needs and function. Kita akan buat tutorial. Okay, sama je macam yang sebelum. Okay, selanjutnya kita akan inilah dia punya ni. Selanjutnya kita akan tengok application of the mixture product. Okay, and then kita define the net function and then we define the set of the properties. Okay, kita akan tengok dia punya tu. Okay. So ini dia punya step. Okay, needs function. A single molecule solvent product must at least be a liquid at the condition of reaction and must dissolve as an assigned solute. What should be the required properties of the solvent? Sebenarnya satu isu yang penting yang relate pada molekul dengan mixture design adalah set of the properties lah of the single molecules ataupun the mixture. Okay, dia akan define produk punya needs function tu sebenarnya. Okay, itu salah satu dia. Salah satu dia adalah kalau kita tengok kat sini adalah single molecule tu kan, solvent product must at least be a liquid. Okay, at the condition of the application. Sebab jarang lah kalau kita guna yang bukan liquid kan. Okay, and then kalau you mix dia kena dissolve, dia kena homogeneous. Itu dia punya conditions lah. Okay, so bila you mix kena homogeneous, bukan ada two phase ke, dia mesti single phase. Itu yang awak kena tahu. Okay. Okay. Salah satu lagi adalah the properties values lah. This is required. Okay. Kalau you nak measure daripada database ataupun nak retrieve daripada database and then you nak calculate. Okay. So generally we will measure experimentally. Kadang-kadang kita boleh dapat daripada database lah. Okay, dalam software tu. Okay. Ataupun kita calculate lah. Ini ada property value. Okay. Untuk computer aided techniques, okay, kita kena include lah database ni untuk kita measure the proper value. Okay. So kita boleh dapatkan daripada library of the property models, okay, untuk predict the property value. Okay. Ini memang penting lah. Kalau you tak ada information, contohnya you nak calculate thermodynamic side. Okay. Sebab nanti even pada untuk design the device saya rasa, okay, you need maybe information about the kinetics, okay, thermodynamics, okay, as well as mass transfer, heat transfer. Memang ini you perlukan daripada database. Okay, kalau property data tak sufficient, okay, you kena generate lah. Okay, daripada building block ataupun group vector. Building block ni contohnya macam dia ada CH3, CH2, OH, apa lagi, COOH. You have to generate, you have to combine to form the molecules. Okay, Yang ni cakap through a set of rules that ensure their molecular stability. So yang saya kata the group of building blocks. Okay, you know the building block such as if carboxylic acid, it should be have a COOH, right? Alcohol OH, right? And then combine with CH3, it's going to be methanol. You have to generate and predict. Okay. Some property model also require structural data. Okay, advantages to use these building blocks to predict molecular properties. Okay, itu yang penting lah. And then finally you have to check to match with the target properties. Okay. Yang tadi tu adalah molecular structure. Okay, kalau mixture blends composition you kena confirm lah. Okay, what's the molecules that you mix already. Yeah. So dia kena stable dalam liquid phase. Okay, jarang lah kita tengok vapor. Tak ada saya biasanya liquid lah. Okay, so even kalau you design what else, toothpaste is liquid, right? Paint is liquid, right? Okay. So you have to use the appropriate property models and then to estimate the needed properties value. Okay. Then tested for the match with the target properties. Okay. Sebenarnya yang paling penting needs function sebenarnya. Without needs function you tak boleh nak predict lah. Okay. Apa needs, apa dia punya function. Okay. Okay. So this is the essential ingredients for the molecular design and also mixture design. Okay. First adalah method to represent stable molecular structure. That we have to implement. You cannot use something that not stable, like they have a radical. Okay. Method to generate chemically feasible molecules and method to estimate the required properties. While for the mixture designs must be homogeneous, which is stable mixture blend candidate, and also a method to estimate the needed properties. Okay, so kalau kita tengok, kita ada banyak sangat kalau awak nak generate daripada building blocks pun ataupun group vector kan, sebenarnya banyak kita boleh generate. Okay. Tapi bila tak ada systematic, macam mana you nak dapatkan you punya target component tu kan. So that is you need the systematic framework lah to generate the molecule structure and test their properties using appropriate computer-aided methods and software. Itu awak kena ingat. Kenapa kita perlukan framework sama ada you guna CAMD maksudnya dia ada flow lah. Okay, what you have to do for the first step and next step, right? And some molecules they have many molecules they have isomers, right? E, Z, trans, cis, that is the isomer. Okay, mirror. Kalau you ingat balik lah. Kalau awak dah belajar. Awak dah belajar kan dekat organic chemistry kan. Sebab tu you perlukan systematic framework. Okay. Berapa molekul you boleh generate. Okay, apa dia punya constraint. You have to generate maximum of how many building blocks of group vector for one molecule. So what is the maximum? Itu you kena consider lah. The boundaries. Yeah. Okay. So for the framework for the CMD, this one is the CMD is for the molecular, while for CMBD is for the blend. Okay, computer-aided molecular design and mixture blend design. Kalau awak tengok kat sini yang biru. Okay, so kita akan tengok molecular structure representation, generation, prediction, problem formulations, and what is the solution. Later for the case study, we will do the case study. I think is by using ICA software. Okay. How to predict the solvent or the molecules. Okay. Kalau awak tengok di sini, kita ada activity how to translate the needs and function into the properties. Okay. Given the list of needs, function, application of the molecular product single type of molecule, right? Could you please translate it into the measurable properties? Okay. Provide 3 example molecules existing chemical which can satisfy the needs, function, and provide the values of the properties. Post the answer in the Jamboard. We provide the Jamboard. Wait, Chapter 3, Activity 1. Kejap. Here are the list general case study application. The solvent must be in liquid form at the extraction process of 25 degrees C. Right. Kalau yang ni dia relate dengan apa? Okay. To avoid harmful condition, especially when the process is near to ignition. Yang ni relate dengan apa? Perfume is a mixture of fragrance oil in solvent. When perfume is a spray, the solvent needs to be evaporated right away, leaving the fragrance compound in the perfumes. Okay, saya kasih link tu. Awak masuk Jamboard. Boleh tak awak dapatkan dia punya properties and also chemicals lah. Contohnya yang ni kalau in term of solvent at the liquid form, apa dia punya properties? Okay, something that can be measured. And what is the chemicals? Kan kat sini, given the list of needs function of the molecular product, translate into the measurable properties. Yeah, measurable properties. Sama. Measurable properties. Measurable properties macam viscosity, apa lagi? pH, that is measurable properties lah. Provide 3 example molecules. 3 example molecules which can satisfy needs functions that provide the value of the properties. Yang ni need the function lah. Solvent must be a liquid form at the extraction process. Go to page berapa? Chapter 2. Chapter 3. Chapter 4. Properties. Bawah ni properties. Awak kena isi. And then tak lah. Ini properties lah. Properties. And then chemicals. Yang ni 1. Yang ni 2. Yang ni 3. Okay. So mohon isi properties. Alamak. Cuba letak ethanol. What is the properties? Measurable properties What is the measurable properties? Kena. Measurable properties. Ethanol. What are the chemicals? What is the measurable properties that related with the solvent must be in liquid form at the extraction process?
Dia punya concentration boleh kira measurable properties ke?
Apa dia?
Concentration.
Concentration. Concentration boleh saya rasa. Concentration is measurable. Kan?
Sebab dia sample persen kan, berapa persen yang kita pakai kan?
Hmm.
I think so.
Concentration boleh. Concentration. Kerosene. What is the measurable? Kalau solvent must be in liquid form. Yang tu apa? At the extraction process of 25 degree. Ini biasa. Kalau awak tengok. Must be liquid. Must be a liquid. To avoid, kalau yang kedua, to avoid harmful condition, especially when the process is near to ignition source. The solvent used in the process must be non-flammable. Kan? Boiling point. Satu. And then what is another one? Biasanya. Dia bukan setakat boiling point tu. Kalau flammable.
Flash point.
Flash point. Nombor dua. Kan? So nombor dua tu flash point. Kalau yang ketiga tu, yes. Boiling point. Saya dah kasih jawapan. Apa lagi? Pressure. Pressure gradient. Kena tulis kat situ. Freeze point. Freeze point ni lah betul lah kot. Freeze point kan. Apa yang ni? Apa selain freeze point? Nombor satu. Corrosion. Corrosion ni nombor apa ni? Corrosion. Nak nombor dua ke nombor satu ni? Corrosion. Corrosion ni nombor apa? Cuba bawa. Corrosion ni siapa letak corrosion lah? Naim, tulis lah sini. Tadi saya dah kasih tahu jawapan. Yang lain? Boiling point, okey. Mana lagi? After density. Okey. Kena tengoklah group. Density. Ini melting Nombor satu ni biasa kalau ni dia relate dengan melting point. Sebab dia ni kan. Okay? Okay lah. Tu dah faham The measurable properties, and daripada measurable properties, daripada needs of function tu you kena tahu lah. Okay. Kita sambung. Hari ni sampai dalam setengah lah. Alamak. Okay. So let's we continue on the framework for the computer-aided molecular mixture design. So there is a flow or the step that we have to consider. Since I already explained that there's a many number of the molecules that we can generate. Okay, whether it's feasible or non-feasible, meaning that there's what we call it as a stable or unstable, right? Okay, and it is a huge molecule that we can produce. Without the framework, we cannot identify. That's why we need the framework to generate the molecular structure. Okay, so awak kena ingat lah. Okay. Okay, so kalau awak tengok kat sini, this one is just okay, computer aided framework for the molecular mixture design. Okay, generally we use CAMD lah, computer aided molecular design. That one, CAMD. CAMBD is for blended. We can obtain by 5 hierarchical step. First, kalau tengok kat sini adalah problem formulation. Okay. So kita define as in term of the product needs and function. Yang tadi biasanya kita akan convert daripada qualitative to the quantitative lah. Okay, this is to identify the goals of the design operation. And then second is the method and constraint selection. Okay, needs and function. Kat sini we convert into specific set of the properties. Macam tadi tu, when we identify the needs and function, we convert to the measurable properties together with the their target values lah. Itu yang awak kena ingat. Okay, contohnya tadi you convert kepada something that measurable properties, right? And then what is the chemical? And then by using computer-aided molecular design solutions lah. This is to identify compound having the desired properties. Okay. For example, the group contributions. Okay. Kita akan test candidate tu lah. Okay. Whether by using CAMD ataupun CAMBD technique boleh generate a molecule structure mixture ataupun tak. Okay, and then we can calculate dia punya properties. Okay, together dengan dia punya target properties. Faham And then yang keempat adalah result analysis and verification. This is further the candidate lah after you screen by using CMD solution. Okay, you will do subsequent analysis to confirm the desired performance. Okay, so this one you analyze and suggested compound using external tools. Okay, faham and then finally is a candidate selection lah. Okay, final selection. So dekat sini kita akan based on the detailed verifications, you combine between the simulation and also experimentals and also the rigorous model based test. Okay, you boleh dapat apa you punya target compound. So kalau tengok kat sini kita akan ada loop sebenarnya. Loop ni kalau tengok kat sini not suitable solutions. Okay, due to the performance, economic, safety concern. So kita kalau tak, memang dia akan loop balik lah daripada awal. Tak boleh finish lah. So dia akan loop balik. Ni dua ni penting. Okay, dia macam ada. Hari tu saya dah explain kan stage gate kan. Dia macam tu kan. Kalau tak boleh pergi kita akan patah balik lah. Faham So kalau nak tengok typical application untuk framework ni adalah yang ni lah. So objektif dia kalau tengok kat sini, to find environmentally friendly substitute molecule for benzene. Only the concept is. Benzene ni sebenarnya, yelah, kalau tengok pun memang carcinogenic, right? Kalau sekarang ni dekat universiti pun kita dah, apa lagi komponen yang kita ban like a hexane, we have to find the substitute for the hexane. What else dimethyl, diethyl, saya lupa. Dichloromethane saya lupa pula. Okay. So yang tu semua memang carcinogenic. We have to replace with another solvent ataupun components lah. Okay. Tapi selalunya kalau kita tengok solvent yang safe ni, dia punya performance dia tak efficiency dia tak tinggi kalau untuk extraction tu berbanding yang memang untuk yang toxicity ni kan. Tapi in term of safety we have to replace lah. Okay. So kalau tengok kat situ kan, kalau kita nak replace the benzene, okay, the first step 1 and step 2 is a pre-design, right? I want a cyclic alcohol ketone aldehyde and ether with solvent properties similar to benzene. Kita dah ada target lah. Okay. So something that a substitute lah yang environmental friendly alternative likely to be cyclic and is a molecules kan kat situ kan, alcohol ketone with CHO lah. Kalau benzene memang organik lah, CHO, of course have CHO atoms. Yeah. And then the interpretation to the input, we have a set of the buildings, for example, like a functional group. If look at here that, ada ni tak? Ada ni. Tak ada apa orang panggil dah. Pointer. Tak perasan lah kat sini. Ada pointer tak? Tak ada. Tak apa. Saya guna mouse. So we will generate the set of the building block. For example, like the functional group is like OH, COOH, CO, C, CHO for aldehyde, ketone, right? Okay. Together with the set of the constraints kalau awak tengok kat sini, set of number of constraints to generate candidate molecules. Okay. And then we go to the design, which is the step 3 and 4. Okay. So kalau awak tengok kat sini, a collection of group vectors like 3 CH3, 1 CH2, 1 CH, 1 CH. All group vectors satisfies constraint. So kita punya target contohnya kalau kita nak dalam satu molekul tu berapa group vector. Okay. Since the same group vector may represent more than one molecule. Sebab kalau kat sini kalau awak combine CH3, CH2, CH, 2O, you boleh ubah-ubah ni. Maksudnya akan ada banyak molecules ni. Itu awak kena ingat. So kita kena matchkan dengan dia punya target properties. Okay. Yang mana boleh replace benzene. Okay. Okay. Kemudian yang ni adalah first order sebenarnya. Yang ni second order lah. Higher levels. Okay. Selepas tu kita akan tengok the second order. Okay. Kita boleh identify atau distinguish the isomer lah. Kalau kat sini dia ada isomer kan. Yang ni kemudian kita akan tengok dia punya mana ni, GCA, Group Contribution Assembly lah. Okay. Finally kita akan dapat kita punya target lah. Tapi yang ni isomer. Okay. Nanti kalau you punya, bila you buat screening, tak silap saya, dia tak ada sampai isomer lah. Yang ni dia sebenarnya. Tapi kalau ada software memang you kena klik yang isomer. Okay. Penat. Ada 30 slide. Okay, faham dia punya step lah. Dia punya framework. Nanti kita akan tengok lah macam nak screen. Okay. Selalunya kalau untuk design proses kita start with the definition of the basic needs lah. What is the ultimate goal? Kan? Okay. Sebab dia akan influence many of the design decisions. Okay. Itu yang kita kena tengok. Selalunya type of goals yang saya cakap tu influence design decisions should describe the functions, okay, environment, equipment and capabilities. For example, yang saya yang you buat tutorial must dissolve at specified solute, something like that. Must be selective if another soluble solids are also present. Must not cause a negative environmental impact. This is non-toxicity lah. Okay. Should be easy to recover. Once you use it, is it easy to recover? That is the desired solvent lah, ataupun untuk you design that design solvent lah. What is the goal actually? Okay. For example, the goals must be clear. Kalau awak tengok kat sini kan, description of the goals can be different types. For example, find the solvent suitable for removing phenol from a wastewater stream by liquid-liquid extraction. The solvent poses a low health risk for user. Should be environmental friendly and could be a single molecules or mixture. Okay, kalau kita tengok kat sini, yang ni adalah well-defined problem sebenarnya. Okay, semua is a detail, right? Properties needed macam EHS, environment, health and safety can be identified kan. Okay. And then kita boleh find that the best solvent lah for this one. Yang ni well-defined problem lah. Okay, how about this one? Okay. This one also the well-defined problem lah. Identify the molecule with the same pure component properties as benzene, such as a normal boiling point is already specified. Well-defined problem. Alternate water partition, coefficient, and so on. Lower environmental impact. Okay. Goal value is given this one, right? Well-defined. Okay. So let's see the panggil apa tu? Yang tak well-defined. Yang ni find a solvent to be used for washing off the equipment which is environmental friendly and cheap. Right. So is something missing kat sini. Okay. Kalau awak tengok kat sini, not a very well defined. One piece of important information is missing. What should be dissolved by the solvent? Kan? Kalau daripada yang ni apa ni, minyak washing off the equipment, right? Printing press. Solvent ni nak dissolve apa kan? Cheap. So this is too general. Okay. So this one is another one which is not very well defined. Okay, need more information. Find the additive, molecule or mixture for the tape so that the tape will stick. Something like need more information lah. Okay. Okay. So this is all the example that whether the target goals is well defined or not. So you can read this one. Okay. So this one is okay. For examples, azeotrope, right? CMD can solve. Okay. Kalau yang ni kan, find the molecule that form azeotrope with ethanol at a pressure of 0.0 atm. Yang ni okay. Okay. So kalau tengok example tu sebenarnya dia highlight need for the knowledge lah. Okay. Base system. Okay, kita nak identify the properties from general problem. Spesifiknya presented lah. Okay. Kalau tengok kat sini selalunya, okay, yang saya nak tekan kat sini kan, needs goal is the qualitative, you have to translate or convert to properties or constraint lah, which is the quantitative. Itu yang penting. Daripada needs tu awak nak kena convert yang quantitative. Itu kena tahu lah. Satu lagi constraints. Constraints ni kita nak tahu dia punya boundary sebenarnya constraint ni. Without the constraint, it's going to be a very large number of components that you're going to generate. Okay. So method and construction objective transform qualitative problem to the quantitative one. Okay. The quantitative problems consist of, kalau tengok S2, needed properties, goal value, right, building blocks, okay, identify method for obtaining properties values. This one yang penting. Okay, kita tengok macam mana kita nak you buat tutorial ni kan. Given the list product to be designed, write problem formulation with consider well defined. Write in your paper, take a picture of it and submit to the Jamboard, write activity 2 and your name. Okay, so kat sini you kena buat problem formulation. Target lah, the goal. Okay, contoh dia kat bawah ni kan. Water purifier kan. Yang ni adalah hand sanitizer, air freshener, hair cream lah. What is your target lah? Kalau kat sini water purifier, target to find the water filter that can remove both organic and metal ions from water. Okay, nampak tak? To find the water filter that can remove both organic and metal ions. Okay, awak pergi ke Jamboard tadi. Next page. Activity 2. Page 8. Okay. Cuba buat awak punya target lah. The target. Hand sanitizer, air freshener and hair cream. Sama macam ni water. Target to find a water filter that can remove both organic and metal ion from water. How about hand sanitizer, air freshener and hair cream? Apa you punya target? Saya tulis tak?
Boleh. Standby.
Okay. You boleh tengok internet. Tak ada masalah. Tak, you punya target. The target of the, what is it? Macam tadi kan, water kan. Nampak ni. Target to find the water filter that can remove both organic and metal ion from water. Kalau hair cream, the target, okay, it should be, kan, target natural looking shine. Natural looking shine to hair. Susah juga ni. Natural looking shine to hair. Macam mana kita nak convert kepada quantitative kan dia? Natural shining. Shining biasa guna apa? Minyak lah. Lain? Lain? Macam mana dengan apa ni tadi? Hand sanitizer, air freshener,
Oh, jap.
agak. Siapa yang buat ni? Alcohol rub sanitizer containing at least 7% alcohol. Woi, ini betul-betul kopi daripada internet ni. Oh, target. Ni contoh hand sanitizer. Hand sanitizer. The solvent should be able to kill. You want to find the solvent that able to kill the germs without causing any allergic reaction and irritation to the skin. Right. Kalau air freshener, you want to find the air freshener that able to remove what is it, odor, right? Ataupun able to remove or degrade the volatile organic compounds lah. Okay, VOC. Macam tu lah. Hair creams. Contohnya, you want to find the hair creams that not sticky after you apply to your hair. Not cause the skin irritation after contact with your your skin also, right? Hair cream. Itu salah satu contoh. Okay. Faham Oh, kepala saya dah sakit lah. Dah malam. Akan berhenti sampai slide 60 lah. Ada berapa slide lagi? 188. Jangan saya tengok lah. Akan berhenti sampai sini kot. Aktiviti 3. Yang ni kita sambung lah nanti. Hari Sabtu. Sebab yang bahagian part 5. No. Part 5 ni I think we not cover lah. We will not cover, I think. We will not cover. And then this one is more to the hands-on lah. For the software. I don't think I'm gonna explain. This one is more to theory actually. Software. This one. The software. This one. I just explained about the ICAS. Okay. This one is more to theory. It's okay. So let's continue. We have 10 minutes. Where we stop? Okay. Kena rehat kejap 5 minit. Sambung terus
Boleh. Boleh juga.
Rehat 5 minit. Okay, kita rehat
Minum air
5
jap.
minit. 5 minit jap So kita sambung. Sikit je sambung. Tak banyak dalam 10 slide. Okay. So kita sambung. Kita tengok methods and constraints lah. So dia boleh katakan boundaries lah. Okay. Okay. So yang saya kata ni goal adalah qualitative. Okay. And then you kena translate kepada ataupun convert kepada properties and constraints lah. This is from the qualitative to the quantitative lah. Okay. So sebenarnya step ni adalah kita punya yang saya kata kita nak transform qualitative problem kepada yang quantitative form lah. Yang sebenarnya yang kenapa kita nak tukar, sebab kalau kualitatif kita tak boleh nak dia tak suitable untuk CMD problem, untuk software tu kan. Okay. Tapi kalau bila kita convert kepada kuantitatif, yes, kita boleh input, okay, kita boleh masukkan ke dalam CMD problem. Okay. Okay, untuk quantitative problem specification, you kena identify ni the properties, itu satu, goal values yang tadi tu kan. And then method untuk obtain the properties values. Okay, yang ni adalah you kena tengok dapatkan how to, macam mana nak dia punya behavior of the product lah, yang you boleh dapatkan. Okay, Kemudian identify the building blocks. Okay. Untuk generate molecular structure lah. Ini yang penting. Okay, selalunya kat situ dia ada constraint-nya. Yeah. Okay. Untuk translation of product ni to the target properties, need to have a knowledge base lah. So kalau dekat sini selalunya memang banyak kerja lah. Okay, kalau awak tengok kat sini pun work need to be done to prepare the knowledge base. Okay, is a time consuming. Okay, and then you have to gather information from the consumer sebab this is a B2C product, everything is from the customer and consumer. Kalau consumer tak suka, maksudnya your product is not success lah. Okay, sebab everything is a profit. Okay, you kena ingat. And kena improve. Okay, yang saya cakap. Okay, improve the quality, you need a new idea so that you can maintain because B2C product is the lifetime is very short. Okay, kalau contohnya macam tu lah yang saya cerita kan, kuih dan juga kuku kan, dia ada je yang dia punya new product kan. Okay, know how to translate the consumer needs into target properties lah. Okay, selalunya expert will be able to provide this knowledge if necessary data is available. Okay. Okay. Another option is you can get from the patents, published article, open source database, journals, right? What else? Wikipedia and so on, so that you can translate the needs properties. Okay. Okay. This is examples. Okay, knowledge-based examples. What is the need? Ability to burn, or the target properties, right? ASTM distillation temperature, safety, flashpoint. This is regarding on the flammable lah. Okay, contohnya gasoline, jet fuels and diesel, right? Okay, this is to identify the characteristic of those three type of the liquid fuels lah. Gasoline, jet fuels and also the diesel. Okay, certain index is related with the engine efficiency, right? Stability, miscibility, environmental effect, oxygen. Okay, what else? Human toxicity, right? This is related with the liquid fuels. Okay. So let's see the example if for the gasoline-based product. High rate vapor pressure, right? This is to ensure fuel is sufficiently vaporized to be burned, right? Low viscosity and also must be stable, lah. Not evaporate easily, do not oxidize. This is the need to target for properties. Okay, for the diesels, okay, this one is which is going to be different with the gasoline, okay, low viscosity, low environmental impact, right? And jet fuels operated at low temperature above ground, high flash point and so on. Okay, this is needs to target properties, the example. Okay. Okay, so knowledge-based example for the lubricant blends need. Kalau tengok kat situ, ability to lubricate and prevent wear, kinematic viscosity and friction coefficient lah. Yang ni kita boleh measure. Yang ni you boleh beri input kepada CMD problem. Okay, untuk software. Kalau tak ada target properties ni, memang tak boleh ni, tak boleh guna modeling. Yang ni biasa je. Okay, lubricant blends, principal functions, reduce resistance and prevent wear between two moving surface, needs obtained through knowledge, based literature search and legislation details and so on. Density, in terms of density, different upper and lower bounds. Okay, ini awak kena tahu lah. Okay, and also actually is kalau knowledge based example ni, okay, information kena ada knowledge base dalam dia punya order of the hierarchical. Itu yang awak kena tahu. Okay. Selalunya kalau awak tengok kat sini kan, for the solvent solvent base. Okay, solvent base should be on the top. Okay. Kalau tengok kat sini root dia unit operation process fluid kan, LLE, VLE and SLE. Okay. LLE ni liquid extraction lah. VLE ni vapor liquid extraction. This one solid liquid extraction. Yang ni non-solvent base, solvent base. Kita divide lagi. Right? Homogeneous, heterogeneous. Ni the hierarchy lah. Okay. Selalunya kita akan ada 3 branch lah dekat sini. Okay, kita ada kalau untuk extractive distillation dekat sini kan, EHS properties, desirable properties and also essential properties lah. Kalau solvent base ni. And then ada pure component mixture properties. Kita divide pada 3. This is for the solvent base lah. This is the hierarchy. Okay, and for the difference right, between essential, desirable and also EHS ni boleh tengok kat sini lah. Selalunya essential kalau tengok kat sini function of desired product. Kalau desirable, performance associate of the product in the specified application. Ini more to the difference lah between essential, desirable and also EHS ni environment, health and safety. So ini dia punya classification. Awak boleh tengok lah nanti. Terlalu wordy lah. Ni tak ni sangat kan. Okay, kalau awak tengok dekat sini, essential and desirable properties, E and D Kalau LL extractions, ini more to ni lah, properties pure, delta, tau, mu, TB tu boiling point lah. Essentials, memang kalau LL liquid extraction, boiling point memang essential. Dia bukan desirable kalau awak tengok kat sini. Kan? Itu dia punya basic concept lah. Kalau liquid extraction, memang boiling point. Extractive distillation pun boiling point. Isotropic, solid separation and also gas absorption. Ini yang salah satu contoh lah kalau antara difference antara essential and desirable properties lah. Kalau density, density liquid extraction. Ni kalau awak understand the fundamental of the unit operation kan, yang you tengah belajar tu, you akan tahu. Okay, kalau tengok EHS EHS health and safety kat sini ada ni lah, toxicity, health, environment. Ni in term of macam mana you nak identify lah. Chemical stability is safety and health lah. Environment not really, reactivity more to safety. Biodegradable of course environment lah. Itu kena tahu. Kalau BOD environment. Kan? LD50 pun environment. Okay. So that is the what we call it as knowledge based examples as well as essential, desirable and also EHS. Dia punya difference. Macam mana you nak tahu dia punya guideline and also hierarchical. Okay. So kita ada dalam 15 minit. Okay. Kalau awak tengok kat situ, in your team, prepare a primary omni knowledge base table with need properties and value if possible based on the product that have been assigned to you during the problem formulation activity. Okay, dekat sini ada 3 hand sanitizer, air freshener and hair cream. Ini tak payahlah, tim ni tak payah Tim ni tak ada awak kena identify dia punya needs, properties and also constraint. Needs dia contohnya kalau hand sanitizer non-sticky ataupun high evaporation rate, right? Properties dia adalah related with the boiling point. Okay. Constraint dia adalah related with the, contohnya irritating to skin. Okay. Itu adalah constraints lah. Kalau dekat sini, apa dia punya constraint lagi ya? Okay, tak ada. Apa lagi kalau in term of hand sanitizer? Maybe the constraint is not evaporated at the ambient temperature. Maksudnya room temperature lah, at 30 degree C ke. Okay, itu dia constraint lah. Okay, yang ni tak apa, saya just kasih tahu je lah. Nanti awak boleh buat lah. Yeah? Next class kita boleh bincang. And then kalau air freshener, contohnya good fragrance, kill bacteria, air freshener kan. This is gonna be the property is gonna be flash point, density. What is the constraint? Kalau air freshener, kalau boleh fikirkan. Not able to to kill the germs. Air freshener untuk kill. Tak.
Betul. Sak.
Hello? Putus-putus.
Tak kill lah air freshener.
Oh, air freshener lain. Itu lain. Air freshener just fragrance je kan. Maybe air freshener is related with the solvent also, I think, kan? So dia solvent tu takkan evaporate lah. Kalau hair cream dia punya constraints maybe too sticky lah, too sticky. Kalau dia punya needs easy to spread on your hair, but is it gonna be related with the kinematic viscosity lah. Okay, what else? Pleasant smell. Pleasant smell biasa relate dengan apa Kalau smell ni, alamak saya tak tengok. Saya lupa. Kalau smell ni. Smell ni more to solvent saya rasa. Okay, what else? Can hold your hair for long time lah. This one I think is more to like maybe related with the friction coefficient. Maybe lah, saya tak pasti. Okay, tapi itulah, itu contoh dia. And restriction maybe irritating to your skin kalau you use hair cream tu kan. Mungkin in term of dia punya apa, the smell lah, tak bagus ke, itu constraint untuk proper formulation. Ini contohnya. Okay, faham untuk introduction lah ni. Mini pula, needs, properties and also constraint. Nanti kalau untuk kita dapatkan kita nak generate candidates, dia ada constraint lah, boundary lah. Okay, ada soalan tak? Sebelum saya stop. Kepala saya dah sakit dah, ting-tong. Ada soalan tak?
Tak ada. Betul.
Calculation next ni lah, next class lah. Malam tak boleh buat calculation lah. Pening lah. Okay.
Alamak, doktor pun dah pening.
Saya pening lah. Malam ada banyak kerja. Aduh, pening lah. Hari Ahad deadline. Okay, ada soalan tak?
Ni kena rehat doktor.
Memang nak kena rehat ni, nak tidur.
Laju
Okay,
je.
faham Semua pun nak tidur ni. Awak semua pun nak tidur kan?
Banyak lagi ke kita punya ni slide? Tak ada dah.
Ada banyak lagi. Calculation belum lagi. Nantilah hari Sabtu okey lah, siang. Malam ni saya tak boleh lah.
Okey doktor, satu.
Takkan kita nak buat waktu sahur kan?
Doktor, yang untuk kelas yang
Boleh,
selepas
doktor.
raya tu nanti doktor akan info betul tak?